into our example. So here's a graph of g of x. And what's different about this example from what we did previously is that that's not a graph that we know. That's not an x squared graph. It's not an x cubed graph. It's just a bunch of lines put together. But even if you have just a bunch of lines put together, you can still move the graph left, right, up, and down. So this one says, sketch the image of the graph after each translation. Write the equation of the image in terms of the function g, and state the domain and range. Okay? So sometimes we have to be careful when we read a question. I don't know if you ever do this when you're doing a math question. You start reading, you hear sketch, and you're like, okay, I'm going to start sketching. Translate it 4 to the left. Okay, I'm going to do that one in blue. That's going to be easy, just 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Take each of those key points and move them 4 to the left, and then play connect the dots. Perfect. We've sketched it moving 4 to the left. And then if you were probably like me as a student, you'd immediately go, okay, B, translation 1 unit up. I'm going to do that one in green. And up 1, up 1, up 1, up 1, zoom, zoom, zoom. And so I translated that one up. And I feel good, and I move on to the next question. Okay? One of the things that, I told you yesterday, this course is an attention to detail course. This is on the side of page 165. So in our examples, there's example 1 that's written, and then right beside it is the question. And there's space for you to write all the work that you need to right underneath it. Now, how many of you are like that? You hit the word sketch, you go, I know how to sketch, you read what you needed to do, you sketch it, and then you would go on to the next question. Okay? Probably lots of us. Okay? In math, it's attention to detail. Anytime you do a question, you're probably going to read your question 2, 3, 4 times. Okay? In math, there's not a lot of words, but you have to read them often. And you have to read every single word, because sometimes in math, one tiny little word change in there changes the whole question. So carefully, I'm going to read, sketch the image graph of after each translation. I've done that. But then the next sentence says, write the equation of the image graph. And then I'm going to highlight this, if my highlighter works, which it doesn't want to. I'm going to highlight in terms of the function g. I'm going to see if my highlighter is working yet. No, the whole thing is frozen. Because another thing that happens in a math class is, you'll do this. You don't even realize you do this. But you're like, okay, Mr. JR is not writing. I'm going to take a mental break. Oh, he's writing again. I'm going to copy that down. He's not writing. Mental break. Okay? And what happens when you get to the quiz is you get this same wording. Write the equation of the image graph in terms of the function g. And you put up your hand and you say, what does it mean in terms of the function g? It's like, well, that's why it's important to, when you get new vocabulary or new ideas in a question, that's a key point to pay attention. Okay, so I will highlight what I know that students in the past have had trouble with the vocabulary, right? And this is one of them. What is in terms of, okay, oh, and also keyword here, equation. So with equation, that means you have to have an equal sign. I'm going to take out my blue pen, because my blue one's for an equation. So I'm going to have y equals. I've already got an equation. And in terms of the function g, means that on the right-hand side of the equation, I need g of x somewhere. So in this case, a translation of 4 units to the left and right happens inside of a function. We've moved the function g of x 4 to the left. How do we show that in function notation? we would have g of x plus 4. So now the right-hand side is in terms of g because it has the function g. We've shown in function notation that 4 units up to the left would be a plus 4 inside the function. And for the green one, y equals, in terms of the function g, it would be a g of x, and then we've moved it up 1, that's outside of the function, plus 1. So sometimes you'll get a question that says, in terms of x, then your equation is y equals, and on the right-hand side you have no function notation, you just have like x squared plus 3 or something just with x. That's what in terms of x means. But if they say in terms of the function, then you'll have function notation on the right-hand side. Okay? One of the biggest things that's learning in this first unit, right? Moving things left, right, up, down, that's not hard. But the notation is something you're going to have to pay attention to. Okay, so now I go back. I'm like, woohoo, I finished the next part. Go on to the next question. No, whenever you finish something, that's the time to read the question again. Okay, in this one, here's a graph. Okay, sketch the image. We've done that. Write the equation of the image graph in terms of function g. Done that. State the domain and range of each function. I'll do the blue one in blue, the green one in green. Now, domain. First of all, and at the beginning here I'm going to switch. I'm going to show you both interval notation and set notation to get you used to both of them. And then as we move along, I'm going to just flip-flop between them so that you are really comfortable with both. Now, if you were asked to write the domain of something, you could choose if you wanted to use interval notation or set notation. Interval notation is, an interval is from one thing to another thing. It always starts with the smallest value and goes to the biggest value. Domain are your x values. So when I look at my blue graph, I ask myself, do I have a smallest x value? From the left, minus 5. I'm going to start with minus 5. And in interval notation, you have square brackets and you have round brackets. If the value is included, which 5 is, you use a square bracket. If the value is not included, you use a round bracket. So our smallest value is negative 5. Our largest value for x, it goes up to 2. It includes 2, so square brackets again. And that's interval notation for the domain, from negative 5 to 2. Not to be confused with a point, because coordinates are written that way too with round brackets. This is an interval, and it means all the x values from negative 5 to 2. In set notation, you would write the same thing with an x in the middle. This means that x is between negative 5 and 2. If you look at each of these separately, let's see if this still works. Nope. All my fancy pens aren't working right now. If you just look at the left, can you see that the left part's, oh, there it is. It's just slow. If you just look at that, can you see that that part means x is bigger than or equal to negative 5? And if I just look at, whoa, wait for it. Okay, I'll just slide this way. If I just look at that part, that means x is less than or equal to 2. Each of those things are true. X is bigger than or equal to negative 5 and less than or equal to 2. Putting those together means you're going to put your x value in the middle. And it's same as the interval. It's going from the smaller value to the bigger value. And x has to be bigger than that smaller value, but less than the 2. And the square brackets in set notation has that equals sign underneath. So there's our domain, our range for our blue one. In interval notation, the smallest y value is 2. Our largest y value goes up to positive 5. And in set notation, you would have to use a y value because now you're talking about range. For our second function, our green function, domain and range, our smallest x value in our green function is 1, negative 1. Our largest x value is 6. In set notation, negative 1 less than or equal to x less than or equal to 6. And for the range of our green function, the smallest y value is a positive 3. And the largest y value is a positive 6. So again, you can choose whether you want to use interval notation or set notation. Some of them you'll like better in one form, some of them you might like better in the other form. You need to know both of them because if you got a multiple choice question or a question where they said, we give you the range, can you find the new range? Okay? Now, notice how we found the domain and range. We found the domain and range by looking at our graphs. That's a very easy way and probably the most typical way to find the domain and range. Okay? But sometimes you're going to get questions. Okay, first of all, if I look at my original red graph here, can you see that your domain goes from 1 to 6 and your range goes from 2 to 5? And you're going to get some questions where they're going to take away everything else. They're going to say, hey, you have a function which you don't get the graph where the domain is 1 to 6. What's the domain if it was translated 4 to the left? Could you go from this 1 to 6, or sorry, negative 1 to 6, there we go. That's better. Could you go from this negative 1 to 6 to this negative 5 to 2 if they said it was translated 4 to the left? Can you see that both of those values you've just subtracted 4? Okay. Now, what I'm doing here is thinking of all the possibilities of asking this same question in different ways. If they said the domain of g of x is negative 1 to 6, what's the domain of g of x plus 4? That's another level of difficulty because you would have to recognize in this function notation that this means a translation 4 units to the left. Could I go, if I was just given the blue equation and the red domain, could I go to this new domain? If I was just given this range and the green function, would I know to go to 3 to 6? I'd have to recognize that the notation in terms of g means it's been shifted up 1 unit, and then know how to affect my range accordingly. So then after we're done a question, and at this point I just finished another section, I go back and I read it again. Here's the graph of y equals g of x, sketch the image graph, done. Write the equation of the image in terms of the function g, done. State the domain and range of each function, done. Okay? So you probably don't notice this sometimes in your math teachers in the past because they reread the question in their head when they're teaching. Okay? But good math students and math teachers, they're always rereading a question. So in math, you often read something 3 times. This is a difference from, maybe I shouldn't put the here, if I'm going to. So then once we're done going through an example, what I'm going to give to you is questions, so 4, 5, 6, and 7. And those are now questions that after we've done example 1, where you can see, am I getting this? And the homework questions for each lesson just happen at the end of the lesson. So that starts on page 169. And usually, the amount of time that I'll give you won't be enough to complete all of 4, 5, 6, and 7. Sometimes you'll get it all done, depending how many people have questions, okay? Sometimes I'll just give you a little bit to get started, and sometimes we're in a rush, we might even, that'll just be for homework. But these are the questions that you will have for homework. So sometimes what people like to do is 4, 5, 6, and 7, they turn to their exercises, they circle 4, 5, 6, and 7. So they know those are the ones so far that I need to do. Okay? I'm not going to assign all of the questions at the back, only specific ones which I think can help you the most. So if you don't finish 6 and 7, or you don't finish 5, 6, and 7, later on when you're looking at your homework, you're like, oh, I was supposed to do those ones. And that's what you'll have for tonight. So I'll give you about 5 minutes right now to get started. I'll answer whatever questions you have.